is important. Forgot about this one. Turning points, we'll get back to that other part. Turning points are considered to be the parts where the graph turns from going up from increasing to decreasing, or from decreasing to increasing. Okay, so we can see on this particular graph that we have 1, 2 turning points, because the function goes from increasing to decreasing at the first turning point, and then the second turning point the graph goes from decreasing to increasing, and so we have 2 turning points. Now, what this theorem is telling us is that an x to the third, a third degree polynomial, can have at most 2 turning points. A fourth degree polynomial can have at most 3 turning points. We kind of knew that already. So just to put a kind of like what we already knew into this theorem here, x to the third looks like that, 1, 2 turning points. Or it could look like this, no turning points. Okay, x to the fourth could look like this. It could look like this, where we have 1, 2, 3 turning points, or 1 turning point. So at most n minus 1 turning points if the degree of the polynomial is n. Okay, so that's a theorem that you need to know. You don't necessarily need to be able to say it word for word, but you need to understand the concept. If I say, how many turning points could an 8th degree polynomial have? 8th degree could have at most 7 at most. So 7 turning points at the most. 8th degree polynomial. And so that also helps us with things like this. If you see a graph that looks like this, you say, well, what could possibly be the lowest degree that that function could have? 1, 2, 3, 4, 5. 5 turning points, which means it is at least an x to the 6th polynomial. Okay, x to the 6th polynomial, at least. Alright, so that's a little bit of background behind turning points. Now let's take a look at the graphs so you can identify some key characteristics of them, and then I'm going to give you some problems. You'll probably already have printed out some problems that you're going to be doing for homework tonight. Okay, back to this. I encourage you to watch the rest of this video before you start doing the practice problems that you're going to be answering online. So for this one, is it a polynomial? You should be able to say no. And why not? Well, the reason why not is because it's got an opening in the graph. It's got a break in the graph. It's not continuous. Okay, and so polynomial functions are always continuous. Okay, try this one. So this one, pause the video if you want to try it on your own, but if you want to think a little bit more. But you should already be looking at this as, yes, that's a polynomial function. For those that could list the zeros are -2, 1, and 2. And the least degree the polynomial can have would be 2 turning points, so a third degree polynomial. Okay? The least degree would be a 3, third degree polynomial. For this one, you should be able to identify, no way is that a polynomial function because it's got a sharp point. Can't have any sharp points. Okay? How about this one? We have a yes, that could be a polynomial function, and y, you've got zeros at -2 and 1, and 1, 2, 3 turning points, so at least a 4th degree polynomial. And you should notice also that the ends of the graph go down, so it'd be a negative first term. Okay. Do we have any more? Okay, we already talked about end behavior, so right now I'm going to go back to this and